This is our section on circles and segment lengths. And we're looking at finding an equation that deals with the relationship between chords and the length of the segments. We have a blue chord, we have a red chord, and we have the intersection point here where they come together. That's going to be the most important point that we deal with in this problem. All of the segments that are going to be in this equation have that intersection point as an endpoint. And as we look at that blue chord, we have lengths of x and y, which have that as an endpoint. And along the red chord, we have lengths of a and b that have that as an endpoint. And the equation then is going to be x times y is equal to the product of a and b. In this example, we have two secants intersecting, and they're intersecting outside the circle at point E. So in this type of a scenario, point E, this intersection point, is going to be the most important. If we look along this blue secant, we're looking for the two segments that use E as an endpoint. Those two segments would be BE and AE. And if we look along the red segment, the two segments that use E as an endpoint would be segments DE and CE. So our equation here is BE times AE is equal to DE times CE. In this scenario, we have a tangent and a secant intersecting outside of a circle. They're intersecting at point E. And we're going to use the same principle that we use for all those other segment circle relationships. Going along this red secant, we have CE times BE. Both of those segments use the intersection point, point E, as an endpoint. And then on this blue tangent, the only segment that we have is segment AE. And to keep it consistent, we have to take AE and square it. So both sides of the equation will have a label of units squared. Here's our first actual example of using these equations. This one we have two chords intersecting. They're intersecting inside the circle at that highlighted point. If we look on this blue chord, there are lengths of 5 and 12 that'll be multiplied. And along the red chord, we have lengths of x and 6 that need to be multiplied. So we go into solving that equation, divide both sides by x, or by 6, and we get x equals 10. In this problem, we have two secants intersecting outside the circle, and they're intersecting at this highlighted point on the right. If I go along this top secant, we have a length of 5 and a length of 12, so we have 5 times 12. And now if we look at the bottom one, there is a length of 9, and the other length is 9 plus x. So 5 times 12 is equal to 9 times the quantity 9 plus x. At this point, it's algebra. Distribute the 9, so it's 81 plus 9x. Subtract 81 from both sides. Divide both sides by 3, and we get negative 21 over 9, which simplifies to negative 7/3. So in this problem, we have a scenario that really doesn't make sense. We can't have a negative value for x, so this would be a no solution. We did everything correct. Just based on these numbers, it's not possible for this scenario to happen. And in this last example, we have a tangent and a secant intersecting outside of the circle. So for the tangent, we need to square that length, and for the secant, we have lengths of 5 and 5 plus x. So on the right, it's 5 times the quantity 5 plus x. Now we'll start and do the algebra. Square the left, distribute that 5, subtract 25 from both sides, then divide both sides by 5, and we get that x equals 15.